Today we will discuss traveling salesperson problem. The problem is given n cities and distances between them. Find a tour through all cities, visiting every city exactly once, such that the sum of all distances traveled is as small as possible. That is, we have to find a minimum cost tour starting from a vertex, visiting all the vertices and coming back to that vertex. Let us see the formal definition of the problem. Let G be a directed graph with edge cost Cij. Cij is defined such that Cij greater than 0 for all I and j, and Cij is equal to infinity if Ij is not an edge in edge set. Let size of the vertices set is equal to n and assume n greater than 1. A tour of G is a directed cycle that includes every vertex in V. The cost of a tour is the sum of the cost of the edges on the tour. The traveling salesperson problem is finding a tour of minimum cost. The n cities and the distances are represented as a graph. Let us consider a problem. Here you have 4 cities or 4 vertices named 1, 2, 3 and 4. The salesperson can select any city to begin his journey. Let us select 1 for starting our tour. Okay, we are trying to solve this problem using dynamic programming methodology. We are deducing a formula for this. G1 comma set 2 3 4 is equal to minimum C1k. C1k is nothing but the cost of the edge 1 to k plus gk comma the set 2 3 4 minus k. 2 3 4 minus k. Okay, what is the meaning of G1 comma 2 1 comma set 2 3 4? It is nothing but starting the journey from 1, that is you are at 1, then visiting the other vertices 2 3 and 4 in some order. It is not that there are 2 is next, 3 is the second and 4 is third one. Okay, it is not like that, in some order. And what will be the, and returning to 1, what is the cost? This is the meaning of the function G1 comma set 2 3 4. See the recursive one. And one more thing you have to remember, you can start your journey from vertex 1, next you can visit 2 or 3 or 4. You have select, suppose you have chosen 2, then you can go to 3 or 4. Suppose you go to visit 3, then you will be moving to 4. From 4 is the last city, nowhere to go from 4, so you are returning back to 1. This will be a tour. Okay, so a similar path will be getting on other nodes also. In every path you are finally returning to the starting vertex 1. You are getting so many paths. Remember, it is an NP-hard problem. You are getting so many paths and you have to find the minimum tour, that is starting from vertex 1 and visiting all the vertices and coming back to the same vertex. you can see this function. It is in recursive in nature. The function g is recursive in nature. This will become g1 comma set 2 3 4 will become minimum of c12. So you remember your k can be 2 3 or 4. K is taking the first value 2, so you are getting 1 comma 2 in the place of c1 comma k. Remember, this function is specific for our problem. We will see the general equation later. So it is equal to minimum c12 plus g2 comma 3 comma 4. How you are getting this c2 comma 3 comma 4, 2 comma set 3 comma 4? Because you are excluding the value k you have selected from the set you are considering. Okay, so from 2 3 4, now k is 2, so you are excluding 2, you are getting 3 comma 4. Then k is taking the next value 3, you are getting c1 3, that is edge 1 3, cost of the edge 1 3, plus g 3 comma, you have to exclude 3, so you are getting set 2 comma 4. Next, k is taking the last value 4, so it is c1 comma 4 plus g 4 comma set 2 comma 3. Okay, to calculate g1 comma 2 1 comma set 2 3 4, you have to calculate the values of this and this. Let us call this equation the first one. Okay, this is the first equation. So let us try to calculate g2 comma set 3 4 and g3 comma set 2 4 and g4 comma set 2 3. Okay, what is the meaning of g4 comma 2 3? Actually, you are at 4 and you are going to visit 2 and 3 in some order, 3 first 2 second, or 2 first 3 second, then returning to starting vertex 1. That is the meaning of this. And its cost, what is its cost of that path? Then let us descend to g2 comma 3 comma 4. What is its value? This one. Say since it is in recursive in nature, that equal to c2 comma k g k comma 3 4 minus set k. K can be take the values 3 or 4. Okay, so you are getting the expression that is minimum of c2 3, that is k equal to 3, c2 3 g 3 comma set 4 and c2 4, k has taken the next value 2 comma 2 4, the edge 2 4 plus g 4 comma set 3. See what is the meaning of g 4 comma set 3? You are at 4, you are next you are going to visit 3, then coming back to 1. What will be the cost? That is the meaning of g4 comma set 3. What is the meaning of g3 comma set 4? You are at 3, you will be visiting 4 then coming back to vertex 1. What will be the cost? Okay, so we have to calculate what is g3 comma 4 and g4 comma 3. Then only we can put these values here and calculate g2 comma 3 4, then putting the value here and calculate the first equation. Okay, let us go to calculate g3 comma 4 and g4 comma set 3. G3 comma set 4 is equal to minimum of C3k plus gk comma set 4 minus set k, which will be equal to C3 comma 4. K can be take only one value 4 there, because only one element in this set. 3 comma 4, that is nothing but the cost of the head 3 4. Then g4 comma null set you are getting here. Okay, for g4 comma null set. G4 comma null set. Why you are getting a null set? Because here k is equal to 4, k is equal to 4, and you are subtracting set 4 minus set 4, so that is why you are getting the null set. Okay, then what is the meaning of g3 comma 5 actually? What is its meaning? Its meaning is you are at 4, nowhere to go, and you are going back to 1. That is, you are taking a journey from 4 to 1. 4 is your last vertex, or you have visited 4 as the last city. Then what you have to do? Go back. What is the cost? So g4 comma null set is nothing but the cost of the edge for 4 to 1. What is the cost of the edge 4 to 1? Let us check the graph. 4 to 1, 4 to 1, it is 8. So g 4 comma null set, it is equal to 8. So what is g comma 4 comma 5? It is 8. Similar way you can calculate g2 comma 5. It is nothing but the cost of the earth 2 to 1. It is 5. What is g3 comma null set? It is the cost of the edge 3 to 1. It is 6. So you calculate all the values, and you can put this value here. You can put this value here. Okay, what is c3 comma 4? What is c3 comma 4? Cost of the edge 3 to 4. What is it? Cost of the edge 3 to 4. 3 to 4, it is 12. So cost of the edge 3 to 4, it is 12. It is 12. Then G4 comma null set, its value is 8, so it is 12 plus 8, it is 20. So G3 comma 4, you got the value 20. Then next we can take this value and substitute it in the previous function. 3 comma 4, 3 comma 4, and you have to calculate 4 comma 3 also here. Okay, the similar way you can calculate 3 comma 4, you can calculate G 4 comma 3 also. Okay, and that will be 4 comma 3 will be 15. 4 comma 3 is 15. Similar way you can calculate 3 comma 2 and 4 comma 2. 3 comma 2 you will be getting 18, 4 comma 2 you will be getting 13. Okay, next let us go back to put these values in G2 comma 3 4. What was G2 comma 3 4? G2 comma the set 3 comma 4. It was here, it was minimum of C23 plus G3 comma set 4 and C24 plus G4 comma set 3. Now we have the values G3 comma set 4 and G4 comma set 3, and we know the edge goes 2 3 and 2 4. Okay, what we are calculating here, actually we are at 2, we have visited 2 and which is minimum 3 3 2 4 1, is this minimum or 2 then 4 3 1, which is minimum, we are calculating that. Now we can substitute these values, we will be getting G2 comma 3 2 comma set 3 4. So that is minimum C2 3. What is the cost of the edge? 2 2 3. Let's check the graph. 2 2 3, 2 2 3, it is 9. Then what was, okay, C24 2 2 4, it is 10. Then what is G3 comma 4? 3 comma 4 is 20, and G4 comma 3, it is 15. G4 comma 3, it is 15. So now you are getting minimum, you have to calculate minimum of 9 plus 20 and 10 plus 15. Which is minimum? 10 plus 15 is minimum. What is 10? It is 2 to 4. So 2 to 4, 2 to 4. Then from where you are getting this 15? It is G 4 comma set 3. What is the meaning G 4 comma set 3? You are at 4, next you are visiting 3, then returning to 1. So you are at 4, you are visiting 3, then returning to 1. Okay, so you have decided 2 to 4, then 4 to 3, then back to 1. Okay, then you are calculating the function 1, the first function, and in the same way you are calculating G 3 comma 2 4 and G 4 comma 2 3, and G 3 comma 2 4 is 25 and G 4 comma 2 3 is 23. Now we can go to the first equation, that is G 1 comma 2 comma 3 comma 4. Okay, that is the cost starting from 1, visiting 2 3 4 in some order and returning back to 1. What is the cost? We have already told you are getting 3 costs, 2 2 3 or 4. Whatever the cost, you are getting 3 costs here, you will be finding the minimum. Now you know, see our path was 2 to 4 to 3 to 1. Okay, then we have to calculate which is minimum at this level. So it is minimum of C12 plus, that is you are going from 1 to 2, plus G 2 comma 3 4, from 2 visiting 3 and 4 in some order and returning back to 1. You are adding these two values. The next element is C13 G3 comma 2 comma 4. Next element is C14, that is from 1 you are visiting vertex 4 and then 2 and 3 in some order and returning back to 1. Okay, you are getting these 3 values. Now we have calculated all these values, we can substitute and find the value. So you are getting C12, the edge cost is 10, and we have already calculated G2 comma 3 comma 4, that is equal to 25. That is equal to 25. Then C1 the C13 costed 1 2 3, it is 15, plus G3 comma set 2 comma 4, we already calculated, it is 25. Then last one, C14 costed 1 to 4 is 20, and plus G4 comma 2 3 we have already calculated, it is 23. So 3 elements, which is minimum? 10 plus 25, it is minimum. That is the first element, this one. That means 1 to 2, then from 2 to 3 and 4 in some order, then returning back. So the path is 1 to 2, then 2 to 4, 4 to 3 and 1. Let us check what is the cost of these edges. 1 to 2, 1 to 2, it is 10. 1 to 2, it is 10. Then 2 to 4, 2 to 4, it is 10. 4 to 3, 4 to 3, it is 9. Then 3 to 1, it is 6. So it is 10 plus 10 plus 9 plus 6, 20 plus 29 plus 6, it is 35. So our path is 1 to 2, our path is 1 to 2, 1 to 2, then 2 to 4, 2 to 4, then 4 to 3, 4 to 3, then 3 to 1. This is our path. One to 2, 2 to 4, 4 to 3, then 3 to 1. Total cost is 35. Then next, what is the application of this TSP? Suppose a serviceman, he want to service the equipment in different cities. Considering the cost of travel and time, he can decide a schedule, which city first, which city second, like that. Then another application, a delivery truck. Considering the fuel cost, it can schedule its delivery. So these are the real-time application of this TSP, traveling salesperson problem. The next video we will try to design a approximation algorithm for this TSP. This TSP is NP hard. Okay, thank you.